All right. Good evening, everybody.
Good
Good evening.
evening.
Good evening, everyone. So wait, nobody snapped them out. Good evening, everybody.
Good evening, sir.
Good evening, sir.
Oh, you're one for only three per. Oh, respect. All right. Bless up. I'm wondering what is happening to you all. Why are you not talking? Some persons, I've never heard their voices in this class. Dear, oh dear, oh dear. Oh, Farah, don't forget my cake. Good evening, Tishana. Don't forget my cake. Watch the timing. Stacia, I'm not sure why you're not hearing me because I'm talking through my microphone. So I think you need to exit the class and re-enter. Or I need to connect your audio. I'm not sure what's going on. All right. Okay, guys. Sorry for being late. Circumstances beyond my control, sacrifices have to be made. So I am here. Better late than never. Okay. All right. Who's gonna remind me of where we last left off last week? Well, we weren't here last week Wednesday because last week was Ash Wednesday, right? So where were we the Wednesday before? We should be moving to is it enlargement tonight? Confirm? Did we do rotation the last class? Somebody double check for me in your notes. What was the last thing that we did? I think we're on the topic of transformation. Where are my students? Why are you not talking to me?
Yes, sir. We did rotation last class.
Sorry, not hearing you. I don't know what happened, but I'm not hearing you. Anyone else hearing me?
We are hearing you. Are you hearing us? Hold on, wait. Let me see here. We're hearing you. I'm typing. We are hearing you. All right. Not sure. All right. Okay. So last thing that we did was rotation. So tonight we should be moving on to enlargement. Enlargement. That's the topic for tonight. I saw my teacher did something today, and I want to catch him. I think he did something like. All right. So I think he did something like. So enlargement transformation. Transformation. All right. And he did something like this. Oh, okay. Not sure if he did something like this. Oh, there it is. That's what he did. Right. Lovely. I don't know what he did. All right. All right. Just something like that. I don't know. Something like that. All right. So that's what we're doing, guys. Enlargement transformation. All right. Let's get into it then. All right. So take some definition from you guys. Some important information that we need. Starting to take some notes. Enlargement is defined as enlargement is defined as a change in the size of an object. Enlargement is defined as a change in the size of an object. Enlargement is defined as a change in the size of an object. All right, so we're going to say that this is called a change in the size. All right, too very often when I ask students over the years that I've been teaching this topic, too many times when we ask students, what does an enlargement implies? The first thing they go off is they see the word large and just automatically assume that enlargement means that the thing gets larger, and that's not necessarily the case. So in this case here, the correct definition via the Oxford Dictionary, you'll find that enlargement is defined as the change in the size of an object. All right. Now, there's two ways that an enlargement can take place. So the first type is what we call a magnified enlargement. So we have a magnified enlargement. And we have the other one, which is called a reduced enlargement. I'm not sure why you're not hearing me, Stacy. Everybody's hearing me?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. I think she needs to connect her audio. There's sometimes on Zoom you have to connect the audio to your microphone or something like that. I'm not sure. So this is your reduced enlargement. She tried it already, Abigail. So you have the reduced enlargement. All right, so the magnified enlargement is obviously called a magnification. And the reduced enlargement is called a reduction. All right. All right. Now, continue, guys. More information. Magnification and reduction occurs as a result of magnification and reduction occurs as a result of magnification and reduction occurs as a result of what is called a scale factor. What is called a scale factor. Magnification and reduction occurs as a result of what is called a scale factor. And put in bracket beside the word scale factor, in bracket, you put the letter K. As a result of what is called a scale factor, and put in bracket K. All right, full stop. So, information underneath the scale factor. The scale factor determines the size of the object. the scale factor determines the size of its image. The scale factor determines the size of its image. The scale factor determines the size of its image compared to its object. Compared to its object. So we can see that K is equal to the image length divided by the object length. So that is what is scale factor. The scale factor, the value of K, if they didn't give it to you, then you can find it by comparing the image length and the object length. And both of these must correspond. All right, we'll explain that a little bit later as we go down. All right, continuing. All right, now, the scale factor can be positive or negative. So we can have K. So we can see that K can be greater than 1. And we can also say K is greater than, or K is less than -1. So K can be positive. Let me just write it in words first. So K can be positive or negative. And the way we write that in mathematics is we say K can be greater than 1 and K. So K can be greater than 1 and at the same time K can be less than -1. So that's how we write it. K can be, so first what you do is read it from the middle to the left and then go from the middle back to the right. So we can say K can be greater than 1, meaning that K can be greater than 1, meaning say K can be 2, 3, 4, 5, depending on the size of the graph, as well as K can be less than -1, like -2, -3, -4, -5. Let me write some examples here. I'm really not supposed to do that, but okay. For the purpose of understanding. So we can see less than -1 is -2, -3, -4, and so on. And over here we can see K can be greater than 1, such as 2. So we can see 2, 3, 4, and so on. So if I say a number greater than 1, it means any number that's bigger than 1. 2, 3, 4, 5, 6, 7. Less than -1, -2, -3, -4, -5, -6, -7, and so on. Okay? And what we call this is what we call a, so when K is positive or negative, we call this a magnification. So this is called a magnification. Once K is negative or positive whole number. So we call this a magnification. So magnification. All right, now let's focus some more. Somebody's writing up on my board. All right, let's look now at when K is negative.
Every time we try too hard.
Latisha, your microphone is unmuted there.
Sorry.
That's okay. All right. So when we look now at let's look here. We're gonna look at when k is negative or positive fraction. So k, whoops, k so k, why am I not, okay. I was wondering where's my marker. Okay. So k can be a positive. So k can be a positive or a negative fraction. So what I should have said up here instead, just to be very specific, I shouldn't have just said k can be positive or negative. I should say k can be a positive or a negative whole number. So I should have dropped on the word here, whole number. Such as -2, -3, -4. Well, not whole number because negatives are not whole numbers. So we're going to say a positive or a negative real number. That's what I should say. All right. And then down, I can see that k can be a positive or a negative fraction. So the way we write this on paper is that we say k can be, so k can be so we can say k can be less than, so k can be greater than -1. So k can be greater than -1 and k can also be less than 1. That's how we write it. So it's the other way around. It looks almost the same, but it's different. So k, so if you look carefully here, you see where we know that k can be greater than -1, which the number greater than -1 is 0, but at the same time, k can be less than 1. So it's somewhere between here and here. All right. So any number that is stuck between -1 and 1, with the exception of 0, where k cannot be equal to 0. So k cannot be equal to 0. Because if k is 0, then that means the object is going to disappear. So k cannot be equal to 0. All right, I know this is just a bunch of notes and stuff, and I know you want to see it on the graph and how it looks. But let us continue, because we need the notations to refer back to this when we're actually doing the thing. So I'm going to do some sketches for you now. Some sketches first, not the actual graphs. I'm going to do some sketches for you. And let us look at what we're about to see on the actual graph paper. All right. Now, I'm going to have 4 graphs drawn for you here. So here's my first line. All right. And here's my second line. All right. Beautiful. So that's one graph. I'm going to have another one here. I'm going to have another line here. I'm going to have another line here. That's my second graph. Let's do these two. Let's do these two first. Okay. All right, lovely. So let's have a look at this. So I'm going to make a sketch, not an actual plotting, but a sketch. So I'm going to go ahead and I'm going to make a sketch here. I'm going to say that this is my object. I'm not going to use these straight lines here. All right, lovely. So I'm going to make a sketch. I'm going to show you what happens when an enlargement takes place. So here's my, and I'm going to call this my object. It's just a right angle triangle. Okay. I'm going to call this O. That's my object. Now, watch me draw the image now. Lovely. So do you notice now that I is bigger than O? So this is what we call a magnification. When the image is greater in size than the object. So once I is bigger than O, then we call that a positive. Well, we call this a magnification, right? But we're going to be specific shortly. So when I is bigger than O, let me just go here. So when I don't know what's going on here, guys. Hold on. Okay, so this is when can you write this down for me, guys? For this diagram, for this sketch that you have here? Because it must be the writing not working for me tonight. Not sure why. So write this down. Also, underneath this information, right down here, write it down for me. When the image is larger than the object, when the image is larger than the object, when the image is larger than the object, and you can put I greater than O, you can write that after that. When the image is greater than the object, when the image is bigger than the object, and they are both on the same side. When the image is larger than the object, and they are both on the same side, and they're both on the same side of the center of enlargement, and they're both on the same side of the center of enlargement, this is called a positive magnification. This is called a positive magnification. When the image is larger than the object, and then you can write that symbol down there, I greater than O, and they are both on the same side of the center of enlargement, this is called a positive magnification. This is called a positive magnification. And this can only occur, all right? This can only occur when K is greater than 1. That's the only time this can happen. So if you have a number where K is 2 or K is 3, once K is 2 or K is 3 or K is 4 or 5 or 6, once K is greater than 1, the image will be larger than the object and they're going to be on the same side. Okay? You're going to be on the same side. Stacy, are you in the class?
Yes, sir. I'm here.
Oh, okay. You got connected. What was the issue?
I don't know what happened. I called my son to fix it for me. So he did that.
Yeah, so are you using your computer?
Yes, I'm using my computer.
So what happens is, because I couldn't communicate, so usually when you're using the computer, you have to be very careful when you disconnect your audio. Because sometimes your audio is connected to the computer audio, and sometimes the audio is connected to a backup microphone. So you have to keep this. You have to keep the system. You have to keep the audio connection the same all the time.
Oh, I get what you're saying. Thanks. Yeah.
Yeah, man.
But you rectified for me though. Thanks.
That's what young people are for.
All right.
Lovely. All right. Next, I was gonna message you a while ago, and send you a video that I made of this some years ago. I guess I'll see that's gonna be better than the class. But all right, you're good to go.
I'm going to need it. Because I miss out. I'm not really understanding what you're saying, but send me the video and then I follow from there.
Okay.
All right, thanks.
Now, we're going to draw another one here, but this time I'm going to draw my object here. Just a shape. I'm just drawing a random shape, nothing too crazy. Okay, but now what I'm going to do is that I'm going to draw the image now. I'm going to draw it bigger, but I'm going to put it on the other side. So notice now that they're on opposite sides of each other. So here, I'm going to call this my O. So I'm going to call this my O. I'm going to still call this my I. But the difference between the two shapes that I've drawn thus far is the fact that they're on opposite sides of each other. That's the only difference. So the first diagram, so we're going to call this diagram 1. And then I'm going to call this diagram 2. So the difference between diagram 1 and diagram 2 is that the I is bigger than the O, but look at the position. This one is called a positive magnification, and the other one is called a negative magnification. So this one is called a positive magnification. No, when my device is freezing, it never usually freezes. So this is called a positive magnification. And this one over here is called, so this is when K is less than -1, like -2. So K is less than -1. And this is what we call a negative magnification. All right, write this down for me, guys. For diagram 2, write this down. All right, negative multiplication. All right, so when I is larger than O, and I is bigger than O, when I is bigger than O, or larger than O, or greater than O, whatever you want to write it, when I is greater than O, but they are on opposite sides of the center of enlargement, this is called a negative magnification. This is called a negative magnification. I haven't done any working out in a Stacy. All I'm giving the students thus far is just a bunch of notes that you can see. So I've shown them any calculation. I'm just drawing a bunch of diagrams and kind of illustrating what is going to happen when we begin to do it. So you don't need to be lost. It's just a bunch of notes.
All right, thank you, sir. Thank you, sir.
So don't worry about it. You'll be okay. If you're lost, then everybody is lost.
Sir, could you please repeat the last part?
Okay, so when I is bigger than O, or larger than O, or greater than O, however you want to write it, and they are on opposite sides of the center of enlargement, or they're on opposite sides of each other, if you want to say that. They're on opposite sides of each other, or opposite sides of the center of enlargement. This is called a negative magnification. This is called a negative magnification. I'm going to draw 2 more diagrams now. I want to pay attention closely to what it looks like, ladies and gentlemen. Because all the diagrams look similar, you know. So you have to watch it very carefully. Oh, you can do that? Wicked. I didn't even know you can do that. That's crazy. I didn't know you could do that. Wow, bro. All right, good. And then I have this one right here. Lovely. All right, so these two diagrams now. So look carefully now. I'm gonna draw my O. I'm just drawing a random shape. Okay? You'll be given specifically which shape to draw, but I'm just drawing a random shape. So here's my random shape now. I'm gonna use a different color here. Let's use green. And let's zoom this up for you. Okay, lovely. So here is my O now. I'm going to draw it a little bigger. Just a little bigger. I'm going to call this shape O. But look at what happens now. Look at the eye now. Oh, hold on. Let me just use this color. Look at the eye. You notice that diagram 3 look just like diagram 1. I'm going to zoom it out shortly so you see. So look at diagram 1 and look at diagram 3. Look at them. They're both the same diagrams. Not true? But can you see the subtle difference between them? Can you identify the difference between them? Diagram 1 and diagram 3 is almost the same diagram. But look at where the I and the O is. In this case, I is smaller than O. So this is what we call a positive reduction. So write that down for me, guys. When I is smaller than O, when I is smaller than O, so when I is smaller than O, and they are both on the same side of the center of enlargement, and they are both on the same side of the center of enlargement, and they are both on the same side of the center of enlargement, and they are both on the same side of the center of enlargement, this is called a positive reduction. This is called a positive reduction. This is called a positive reduction. So the reduction, guys, is because the image is smaller than the object. That's why we call it that. But why it's positive is because they're on the same side. So in the next shape I'm going to draw then, you'll see now that I'm going to therefore go ahead and draw my object again. Let me just zoom it up a little bit. So here I'm going to draw. That's my object. I'm going to leave that O. But look at it now. I'm going to go ahead now. I'm going to draw the image. But look at where I'm going to put the image. And the image, once again, is still smaller than the object. But the difference is that they are on opposite sides. So look how diagram 2 looks just like diagram 2 and diagram 4 almost looks the same way. But the difference is that my object is bigger than my image. Up here, my image is bigger than my object. So this now is when, so both of these now are when K is a fraction. So this is going to be when k is a positive fraction. Let's go over here. So this now is when k is a positive fraction. So this is when k is a positive fraction. And right, so once a fraction is going to be a reduction. And over here now we're looking at when k is a fraction, but it's negative. So when k is a negative fraction. So all I've done thus far, for those of you who just you just feel like you're just writing off a bunch of notes, it's gonna make sense, you know. The calculation is going to be so simple, and you're probably gonna be asking me, then, sir, why you tell me all of them something here? Like, why did you tell me all of this? Do we need to know all of this? Not necessarily. Because whether you know it or you don't know it, it's not going to prevent you from answering the question. But you know, when I'm teaching, I have to ensure that I cover all my bases. So I want when these pop up, I can use these as reference and I can say, okay, guys, look at diagram 1. What did we say about diagram 1? Is it positive magnification or negative magnification? Is it positive reduction or negative reduction? Because he's going to ask, you know, they're going to ask you to describe what happens. And when you're doing the description, right, when you're describing a transformation, especially enlargement, you have to tell them whether it's positive or negative, where it's been enlarged from, and the scale factor. We're going to talk about that in our next class. Okay? All right, so don't worry about it. Don't feel flustered. Just go and take off your notes them. Your notes is going to be your reference. Okay? All right. Let's put it to practice then. Let us see. Let's literally try to do a question, right? And see how the calculation is done. So this here, let me just see if I can duplicate. So I'm going to go ahead then, guys. I'm going to duplicate this thing right here. All right. And then I'm going to take it up. I'm going to carry it all the way down here. And then I'm going to reduce the size of it, right? We can use it as reference. All right, lovely. I'm going to use a line here. I'm going to part off this right here, so lovely. Okay, and then I'm going to use this here and box off this right here, so I'm going to use this as reference here. Lovely. So we're just going to use this in the box as reference, okay? Now, here's what I want you to do for me, and hopefully, I told you, you're supposed to have your graph, you know. Please ensure that you have a graph every Wednesday, because we'll be doing a lot of graph topics on Wednesdays. We're going to functions and relations next, right? So, saddle up for that. Oh yes, and I needed to address something as well. I know you guys may have received a message from the administration at the school regarding some third term school fee. I know that somebody may have reached out. I'm not sure who the person was, but somebody may have reached out in the group saying something in regards to getting back some time that was taken from you due to Melissa. Guys, remember, so we don't have no control over that. Rest assured, and I want to assure you, this is Mr. P. If I have to do an extra week in May, then I will. But in terms of giving you back the time that was lost or taken from you by a natural disaster, I can't say for certain that we can do that. We can do our best to up the hours, but I can't perhaps or necessarily say we're going to give you back the time, because everyone across the island lost the time, right? So no one was able to get back any time. You know, we lose it, so we are trying to make it up by, you know, trying. But rest assured, I can tell you this. I've never sent any student in an exam where when you go on the exam, you've never seen a topic. You will see the topic and don't remember how to do it, but you're never going to go on my exam or my exam and then see a question that you don't know, you've never seen before. So I will ensure that the syllabus is completed. So I spoke to Miss Morgan today, and I let her know that if needs be, I will teach you guys, because school closes April the 30th. Or it closes the last Wednesday in April, right? So that's when it would be your last official contract class, right? However, this pool of students was the pool that suffered the most, because when I was teaching face to face, you guys were not having classes, so you guys would have lost out on a couple of hours. If it has been confirmed, that I will be teaching you for 4 extra days straight after April 30. So after the last Wednesday in April, I'll be teaching you for 4 more extra days. So that means not only is class going to be on a Monday and a Wednesday, it's going to be on a Monday, a Tuesday, a Wednesday, and a Thursday. So I'm going to be teaching every day for that week to give you back some of the hours lost. Okay? So for those who are concerned about the syllabus, please remember that is not your job. Your job is not to worry about if the syllabus is going to be completed or not. Your job is to ensure that whatever you're taught, you make sure you comprehend fully what you're taught, or as best as you can. The syllabus completion is my responsibility. And therefore, if I send you in an exam with 3 or 4 topics not completed, that is going to be on the school. And that's not going to happen. All right? It has never happened, and it's not going to happen. So please, guys, just focus on what is being taught and make sure you understand what's being taught, because what is being taught will be enough for you to pass the exam. But will you be able to remember everything you're being taught? So I just want to put that out there, okay? All right. So if anybody is having any concerns about syllabus completion, a long time we are in the game, people. Believe me, I've never sent a student in an exam and you go in there and you see a question that you've never seen before. You see a question you maybe cannot, or you don't remember how to attempt it, but it's going to be a question for sure that you've seen in this class. Okay? All right. So I want to put that out there. All right. Lovely. Let's get back to the mission. So for you guys, if you have a graph, it would be very good if you could follow. But if you don't have a graph, which you should, but if you don't, follow from my lead here. I'm going to go ahead. I'm going to give you some points and we're going to enlarge the shapes. All right. All right. So let me see if I can come up with some points. Give me a sec. I'm going to do a quick sketch, guys. Don't follow me on the screen. Okay. Don't follow me on the screen. I'm going to do a quick little sketch. All right. Let's do something like this. Something like that. Something like that. All right. So let us do something like. Don't follow me, guys. I'm just trying to come up with the points in my head. Okay. So I'm going to go across 1, 2, 3. I'm going to say A is -1, no, -3. And I'm going to go 1, 2, 3, 4, 5. I'm going to go 5. I'm going to go B is, let me see here. B is going to be 1 to my right. And I'm going to go, let's make this -3, 3. And let's make this 1, 5. And then C now is going to be, let's do this. Let's call this 2. And let's call this 2. So that's 1, 2. And go down -1. All right. Okay. So I've come up with my points, guys. All right. So this is the shape that I want you to draw. So if you have a graph paper, ladies and gentlefolks, please plot the following points for me. So please plot the following points for me. I'm going to write them. I'm going to rewrite them for me. So go ahead and plot these points for me. A -3, 3. B 1, 5. And then C is going to be 2, -1. All right, so I'm going to go ahead and try to sketch this graph as neat as I possibly can. For those who are on graph, please ensure that you are able to at least get 10 numbers going up, at least 10. All right, so I'm going to go ahead, I'm going to zoom this up. I'm going to draw it as neat as I possibly can for it to work, okay? As best as I possibly can, I'm going to try. All right, so I'm going to start by drawing my Cartesian plane. So I'm going to go here. I'm going to draw my Cartesian plane like that. I'm going to draw my line like, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to draw it down here. All right. I want to make sure so I can get at least 10. All right. Let's zoom it out a little bit. Come down here. I'm going to come across like that some more. Oops. Come out here. All right, good. So this is my Cartesian plane. So I'm going to go ahead and plot my points now. So remember how to plot a point, guys? The first number is going to be X, and the second number is Y. So X and Y, X and Y, X and Y. Remember how to plot points, right? All right, lovely. Let's go. So -3 up 3. So I'm going to take 1. So I'm going to take 3 steps to my left. 1, 2, 3. And 3 steps up. 1, 2, 3. So I'm going to put my point approximately right here. I'm going to call this point A. All right, lovely. All right, good. So that's -3, 3. That's for me. That's based on the graph that I'm looking at, because I'm looking at the dots. I'm not sure if you guys can see the dots, but I'm using the dots on my graph here. 1, 5, I'm going to take 1 step to my right, and 1, 2, 3, 4, 5 steps up. So I'm going to put my point right here. I'm going to call that B. And then now C is going to be 2, -1. So I'm going to take 2 steps to my right, 2, 1, 2, and 1 step down. I'm going to put my point right here. I'm going to call that C. So therefore then, the shape that I have here is this shape. So I'm going to go ahead then, and I'm going to draw the shape. Deso to deso. And then yeso to yeso. And then here to here. So that's the shape that you are presented with on the graph. Okay? And this is the shape that we're going to enlarge. Now, here are the factors that I'm going to use. I'm going to show you how easy this is. At first, when I was giving you the notes, it sounds a bit complicated, but watch what's going to happen. So I'm gonna enlarge this figure, and I'm gonna give you this. I'm gonna tell you what the scale factors are. Right? And traditionally, when we're teaching this, we traditionally use the number 2 to bring across the point, but it can be 3, it can be 4, it can be whatever number they want it to be. Majority of the time for CXC and the size of the graph paper, they never go beyond 3 and they never go below. Well, obviously you can't go below 2, so it's either 2 or 3. They don't usually go higher than that. So I'm gonna go ahead. I'm gonna use the scale factor. Let's use scale factor. All right, let's use scale factor. I'm gonna use scale factor K equals 2. So I want to enlarge this shape by 2. We want to draw the shape that's 2 times as big as this one. And I'm going to use the scale factor K equals 1/2. All right, just to bring the point across. Okay? Now, believe it or not, guys. All right, and Stacia, this is where I want you to catch me now, because everything that I said earlier doesn't matter. What I'm about to do now matters. All right, so I'm going to do the first one. K is equal to 2. All I'm going to do, students, is that I'm going to take the 2 and I'm going to write it into a matrix form. So I'm going to say 2, 0, 0, 2. All right? You don't really have to do it like that now, but that's how CSEC likes it. So if the scale factor is 2, I'm going to put the 2 in a matrix form like that. 2, 0, 0, 2. Always like that. 2, 0, 0, 2. If it's 3, 3, 0, 0, 3. If it's a half, 0, 0, a half. If it's a third, 0, 0, a third. Always like that. And you're going to take that matrix now and you're going to multiply it by each point. So that's minus 3, 3. That's the first point. Second point is 1, 5. And the third point is 2, negative 1. So all I'm going to do now is that I'm going to multiply each point by 2. And then I'll get my answer to plot. So I'm going to multiply each of those points in the big bracket right here, this bracket, by 2. That's all I'm going to do. Nothing more, nothing less. Nothing harder than this. So let's go ahead and multiply all the top numbers by 2. 2 times minus 3 is going to give us minus 6. Right? 2 times 1 is going to give us 2. And 2 times 2 is going to give us 4. At the bottom now, you're going to multiply everything by 2 now. 2 times 3 is 6. 2 times 5 is 10. And 2 times negative 1 is negative 2. Everybody with me so far?
Yes, sir.
Sir, get lost right here. So.
Which part me lose you? I multiplied everything by 2. So where did I lose you?
Right here, care about the 2.
Right here, sir?
Yes, sir.
Where did I get that bracket from?
Yes, the second bracket.
Second bracket are the points there. Up here, sir.
Here.
So the first point is A, minus 3, 3. That's A. 1, 5. That's B. 2, negative 1. That's C. So I'm bringing back the points that I'm trying to enlarge.
So this part, the top part is X and the bottom part is Y.
That is correct. That is very correct.
Okay.
Lovely. So that's where I'm getting those points. So remember now, A, B, and C is the shape. A, B, C is the shape, and that's the shape that I'm trying to enlarge. And the points of those shapes are given at the top. And so I have K equals 2 right here. That's the scale factor. That will be given to you. Csec will tell you what the scale factor is. And your task now is to try to figure out what will be the image, how it's going to look on the paper. So let's go ahead now, and we're going to plot all of these down here. So we're going to take minus 6. Let's go here. So minus 6. Let me see if we can zoom it out a little bit. So the points are what now? Look at them. Minus 6, 6. I'm going to take 6 steps to my left and 6 steps up to get the shape. So 6 steps to my left. So I'm going to go 1, 2, 3, 4, 5, 6 steps to my left. 1, 2, 3, 4, 5, 6 steps, right? Also. So that's where I landed, right there. All right. I'm going to go ahead and I'm going to, let me give me a sec. Let me just move this information from here. I'm going to duplicate this. Let's see if I want to get this from out of here. All right. I'm going to see if I can cut it. Let me see if I can cut it. Copy. Or let me see, duplicate. Okay, let's duplicate it. Let's push it down here so it don't interfere, and so I can just create some space here. So I'm going to create some space here so that it doesn't interrupt with what we need to do. So I've just removed the points and put them down at the bottom there. All right, lovely. So let's go back to plotting those points now. So we said earlier that the answer is, after we double it, we're going to get minus 6, 6. So 1, 2, 3, 4, 5, 6. Well on. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's somewhere right here. So let me just zoom it up a little bit more here. All right, here we go. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right, that's all. See that? Right, that's all. That's that spot. Like a dot right here. That's all. Lovely. All right. That's minus 6, 6 based on the movements. But you're on your graph. If you're on your graph, you should be okay. So take 6 steps to your left. So take 6 steps to your left and 6 steps up, and you should be okay. All right. Next one is going to be 2, 10. So I'm going to take 2 to my right and 10 up. So 2 to my right and 10 up. So that's 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's all the way up here. All right. Let me just get a little big up marker and show you. Right. That's how you see that. That's 6. That's 2, 10. Up there, sir. And then the last point now is, let's go down here, 4, negative 2. After we double the points, we got 4, negative 2. So we're going to go ahead here and we're going to say 4 to my right, 1, 2, 3, 4, and negative 2 down. So 1, 2, 3, 4, 1, 2. Right, that's all. Put like a black spot right here so you can see it. Oops. Right, that's all. All right. So if we zoom out now, and then I'm going to use a different color ink now to connect them, you'll see how big the shape is after we connect it. I'm going to use green to connect them. I'm going to connect this and this. I'm going to go connect this and this. I'm going to go ahead and connect this and this. And that is what we call an enlargement. So the green one is an enlargement of the black one. All right. And do you notice how they look? If we go back to our previous diagram at the top, look at diagram 1. Look up here, duplicate. I'm zooming it out. Look at this diagram over here. I'm going to show you a duplication. So I'm going to duplicate this diagram right here. Look at this. Whoops, sorry. I'm going to duplicate this. Hold on. All right, let me just duplicate this here. You see that what we have discussed earlier. So I'm going to duplicate this. I'm going to move this over here. Look at it. Earlier when I said to you that diagram 1, the object and the image are what? On the same side. So it's a different shape we have. So look at the previous diagram that we had drawn before the calculation. Do you notice that the green one is I and the black one is O, and they're both on the same side? They're both on the same side. They're both on the same side of each other, right? And if they're on the same side, that means it's positive, and that means I is bigger than O. So notice that green is I and black is O. So it kind of reflects the shape that we have down here. So this was our preview before we actually did the calculation. This is the actual process of how we get it done. So depending on how the shape look and where it is, then that's what we're going to get. All right. Now I'm going to do the one with a half now. I'm going to do the one with a half. I'm not going to do all 3 because it's going to make the graph crowded. I just want you to get the idea. Look at the calculation. It's not that difficult. Look at the calculation. There's nothing much there. All I did was just use the scale factor given to me. And all I did was just multiply the object points and wrote down the answer, and then I plot the answer on the paper, and then I get my image. It's that simple. Let's do the one with a half before we close the class. Let's do the one with a half. Any questions?
No, sir.
Sir, I want to know if this would consider positives.
It is, because
it is.
I told you that K was 2.
Okay, all right.
So K is 2, so it's positive number, and they're on the same side, so it's a positive magnification.
Okay, all right, thanks.
Okay. All right, so we're going to do the one with a half now. So the process is going to be the same. So we're going to go ahead now, and we're going to say K is equal to 2. Let me zoom up here. Let's do the calculation for here. K is equal to a half. So guess what we're going to do? We're going to say a half. Watch me now. a half, 0, 0, a half. You always do it like that. And you're going to multiply it by the points that we have over here. So the original points that we had was the points for the shape up top. Minus 3, 3, 1, 5. So that's going to be minus 3, 3, 1, 5, and 2, negative 1. Those are the original points, correct? So we're going to go ahead now and find half of everybody. That's it. And plot it. Now, you're going to get some decimals, but don't worry about it, because in the exam, rarely do you get decimals, but it's very possible. Okay? All right, so look at this now. So we're going to go ahead and find half of everybody. All right, so half of minus 3, that's going to be minus 1.5. Half of 3, positive 1.5. Half of 1 is a half. Half of 5, 2.5. So, sir, how you go find out on the decimal? Yes, we'll see. Half of 2 is 1, and half of minus 1 is minus a half. Close the bracket. We're going to plot those points now. And then we're going to see how the object gets shrunken. It's going to shrink. Okay? So I'm going to duplicate this here. Duplicate this right here. I'm going to shrink it. Hold on. Duplicate. I'm going to move this over here. Uh-oh. Chai. All right, so I'm going to have to, let me just zoom out a little bit. So I'm going to go ahead and duplicate back this again. Boom. Duplicate. I'm going to move the duplication here. Put it right down here so I can see the points clearly. All right. Since you guys have already had this here, I'm going to go ahead and erase this information. Let me just go ahead and duplicate this one right here. And then we're going to just duplicate this and put it over here. Put it for this calculation up here. And then I'm going to erase this because my shape is going to land into this position. Lovely. All right. Good. Lovely. And then now I can go ahead now and I can also erase this over here as well. Because I already transferred the points up here. All right. So now I'm going to shrink the black one. So I'm going to zoom up now so it gets bigger for you. All right. So we're going to plot these points now. So what were the points that we had? Minus 1.5, 1.5. So 1.5 to the left, 1.5 up. So I'm going to zoom up here. So you can see what I'm going. 1.5. So look now. From the center, watch me now. From the center right here, so I'm going to take 1.5 to my left. So that's 1.5. Right in the middle here, so that's 1.5. Right between the two dots. So 1.5 to my left and 1.5 up. So 1.5 is right between here. 1.5 or right there, so. Right there, so right in the center there, so. Okay? So you're going to take 1.5. Watch me now, you know. 1 and halfway. That's how you get 1.5 negative in that direction. And you take 1.5 steps up. So you should land right here. Somewhere there, so. Okay? All right. Next point is going to be a half to my right and 2.5 up. Half to my right and 2.5 up. So I'm going to take half step to my right. So half step to my right now. half step to my right is going to be halfway here. So right, must see this a 1, you know. That's a 1, you know. So halfway I must break between this, so. And then 2.5 up, so 1, 2, 2.5. So that's about right, so. There, so. Somewhere there, so. So a half 2.5. And like I said, don't worry about it because the numbers that I chose is what's giving me these difficult numbers to find. But usually when we give you on the paper, it's going to be nice numbers. Half of 2, half of 4, half of 6, half of 8, half of 10, half of 12. Easy numbers. And then now the last one that we're going to have to get the shrunken version, we're going to end up with 1 to my right and negative half down. 1 to my right and negative half down. 1 to my right. And so 1 to my right, which is about here. That's 1 to my right there, so. And half down. Right, so. I'm going to use one different color marker now. I'm going to use blue now and connect them so you can see them. So look at the blue one now. The blue one is the shrunken version of the black one. Hold on. Right. So the blue one now is the shrunken version. Now, I know you're probably looking at it and be like, so it's chucked up in? Yes, it's chucked up because of where I drew the black one. I should have drawn the black one more in open space. Right? But you can see that this is called an enlargement. The black one is the object. All right? So the black one, let me see if I can point some arrows. The black one is the object. The green one is the image after the enlargement. And the blue one is the image, but it's the reduction. So it's the IR, and this is the IM. So this is the image magnified, this is the image reduced, and the black one is the object. Okay? Now, this is just the theory, right? This is just the theory. So I want to take, let me see what I know. It's a few minutes left. So I want to show you. So, oh, you guys are not seeing my screen. So I'm going to close my whiteboard here. Give me a sec. I'm going to share my official
I was
screen.
seeing your screen. Oh.
Oh, yeah, no, I know. I'll just close the whiteboard. All right. So are you seeing my screen now? Oh, no, you see my whiteboard, right? Okay. Okay, good. So you should be seeing my official iPad screen shortly. Okay. So let's go onto Google and let's see what we can envision. Okay. We're going to go to Safari. And we're going to type in enlargement. Enlargement in mathematics. All right, good. And what you can see here is that's a bunch of shape. So look at the diagram over here, the first diagram. You can see that that's an enlargement where the image is bigger than the object. So a bunch of them. All right, so look at this one specifically, this one right here. So that, oh, that's a YouTube video. Oh, Lord. No. I didn't want a YouTube video. All right, so this is an enlargement. All right, this is the perfect one. So if you look at this shape here, ladies and gentlemen, look at that one. We have different types of scale factor. Look at the red one, which is the object. Look at the cream one, which is the image. The cream one is larger than the red one. That means it's a scale factor. It's a scale factor that's positive. Look at the one to the right now. The cream one is smaller than the pink one. That's a reduction. The cream one is, so the red ones are the object. The red ones are the pink ones are the object. So the cream one is larger than the red one. If the image is larger than the object, the scale factor is greater than 1. For the second one to the right, top right, the cream one is smaller than the red one, so that's a reduction. Now look at the two bottom ones now. Do you notice that the shapes are on opposite sides? And what did it say for the scale factor? It's a negative number. So when you're on opposite sides, that's when it's negative. But look at it. For the third one, the cream one is on the opposite sides of the red one, but the cream one is bigger than the what? The red one. So that means it's not only is it a magnification, but it's negative because it's on opposite sides. And then now we have this one here where the cream one is on the opposite side of the red one, but the cream one is smaller than the red one. That means it's a reduction, but it's negative. That's why we have negative 0.5, negative 1.5. You guys can screenshot that if you want to. Okay? All right. So I'm gonna send Miss Gentles because, like I said, I don't have my device, ladies and gentlemen. For those of you who have reached out to me on WhatsApp, look at this. Please take down my personal number. I never want to do that in but until I get back that phone, I don't want you guys to be reaching out to me. Check the chat, guys. So it's 876-220 876-220-7352. If you reached out to me and I haven't responded to you for whatever reason, please text me on that number until I get back my phone. Okay?
Sir, the enlargement one was shared with the set that was sent in the group because I went on and I watched it. So it's there.
It was sent?
Yes, sir, it was sent. I watched it.
Okay, how was it?
It was good.
Okay, all right. So,
Yes.
So you can check it out, guys. I think to me it's much better than this class, and I thought this class was kind of just like slow paced and
Yes,
whatever.
sir. The one that is there, it has 5 things there, and it's really good.
Okay, so guys, you
Yes.
can check it out.
And it had
Check it out just
different
to get
range in it. So please know if they see it, no, they will have different sizes, like, because I had to make notes. So it was really good though.
All right, thank you very much.
Yes.
So guys, if you want to find it, all you have to do is just, as you can see on my screen, go on my playlist, and then you can scroll down to transformation geometry and look at the title. You see rotation, it's the center of rotation. Look at that shape here. This one, transformation geometry, enlargement, magnification, and reduction. So you can see them, they're all there. Reflection, rotation, all of them, they are there. So you can click on this one, which is for 36 minutes, and it will give you good clarity. Oh, that's you. You said I enjoyed this session. Oh, thank you. Thank you, Miss Gentles. Okay. All right, guys. So that is it for tonight. Have yourselves, guys, a great weekend. Be safe. See you guys next week, Monday. We will pick up from where we left off last Monday. Have a good night. Good night. Bye. Somebody call me? Yes.
Yeah. I want to talk to you about, you have a class now?